We're back with the same cylinder problem, but now I want to illustrate how this structure, the 5-column, left to right, top to bottom structure, can also help us exploit some of the features of Excel and other spreadsheet software. So the first one I want to show is that this problem, as stated, was how much force can a cylinder of a certain size generate? Well, if you're a design engineer, you may want to solve the inverse problem, which is I need to generate 50 kilonewtons of force. What size cylinder do I need? So, since I have this set up in this column format here, I can use the feature called What If Analysis Goal Seek to solve the inverse problem. Now, in this case, of course, solving this simple algebraic equation for an area and then plugging in d for diameter is not too difficult. But I can imagine, and I have seen many scenarios which are extremely complicated, that I would not want to solve the inverse problem. So we'll at least demonstrate how to do it. So here's what we do. We'll go to What If Analysis Goal Seek. And what I want to do is set this value, which is the external force. I want to set it to 50 kilonewtons by changing one thing. Well, I either have to choose to fix the rod, the pressure. I can only change one thing at a time. So what I'm going to do is change the bore diameter of the cylinder, assuming that it's a 25 millimeter rod, same pressure on each side, and I can at least quickly get the answer. And it tells me to more digits than I care to know. Those digits are not so significant. It tells me I need a 59 millimeter bore with the other inputs as they are to get 50 kilonewtons. Now, if I'm going to order hundreds of thousands of them, maybe I can get a 58.9 millimeter bore. Probably I can't. They're going to come in sizes that are round numbers of some sort. So at least that tells me essentially I need 59 or larger bore to generate that much force. So probably I'm going to end up choosing a 60 millimeter bore cylinder. But that's goal seek. Data, what if analysis, goal seek. Set some value, in this case one of the outputs, to be the target by changing an input that helps you get to that target value. Another thing that I didn't demonstrate yet and is really helpful in spreadsheets like this is to simply add notes. In this case, it's a pretty straightforward problem. I don't know that there needs to be a note, but I could right-click here and insert a note or a comment to simply explain this comes from a force balance on the piston. All right, so notes are there. If you hover over the cell, they pop up so that you see them. But if you don't hover there, it keeps your solution clean. It's like putting comments in traditional code, but so it doesn't clutter the spreadsheet, but all of the comments are there. Another nice feature to add to spreadsheets, particularly if you're going to give them away and for other people to use, is to simply add data validation. So let's go to, I'll just do one of them here. Let's take the pressure on the head of the cylinder. So I'll go there, and under the data ribbon, there is something called data validation. If I can find the right icon. So in this case, I'm going to allow this particular value to be a decimal number. Could be a whole number or a decimal, but I'll allow decimal. And I can tell it to be between, I can force it to be between a particular range. So this is hydraulic systems. Probably it's at least maybe 5 megapascals, and at most maybe 40 with some, high expensive, high strength materials. I would I would enable an input message, which should communicate to the user what is a legitimate entry here. enter the supply pressure in megapascals, and then tell them, acceptable answers, acceptable inputs are numbers from 5 to 40. And then I would have an error alert, some polite thing like, oops, try again with a value from 5 to 40. And once you do that, once the person puts the cursor on that cell, they get the message. And if they try to enter 55, they get an error. Oh, it's got to be a number between 5 and 40, so I'll retry. If I accidentally hit a letter, no, it's got to be a number between 5 and 40. So I can enter in the pressure. So that's simply data validation, which forces, in the case of your inputs, it forces the user to give you a reasonable value. You won't always need to do that, but if you're giving a tool to someone, it's kind of nice to guide them on what is a reasonable entry point value. The other feature to exploit, particularly in spreadsheets that you might give away, is called protection. So that's under the review ribbon. It's called protect sheet, but it actually comes in 2 steps. So under protect sheet, there is the enable protection. I'm going to cancel that because before I do that, I need to identify where would I allow a user to make a change. And so I'll highlight those cells, go to the home ribbon, and bring down one of the formatting menus to see the protection tab. And you'll see by default, this is usually locked. And for these cells that I've highlighted, C3 to E6, that is the input range in this spreadsheet, I want to unlock them. What that does is it sets up for protection, but I haven't done the protection. Now I will go to the review ribbon and protect the sheet. I highly recommend protecting without a password, because if you protect with a password and you forget the password, you are just plain out of luck. So I'm going to protect it without a password. And now if I try to make a change anywhere in the spreadsheet that is not one of the input cells, it won't let me. But if I want to change one of the inputs, absolutely no problem, and I can make that change. Earlier, I had set data validation on column C for pressure 1, but I didn't on the other columns. If I want to replicate that, I could unprotect the sheet, copy that cell, and paste it so that I don't need to go through the steps of data validation multiple times. I'm going to go back and protect the sheet so that a user can't make an inadvertent change. So just to recap, here we did goal seek to solve the inverse problem. We added a note or a comment to document what's going on, illustrated data validation, and then protection to keep someone from accidentally making a change. I'm Dennis Buckmaster, professor in Ag and Biological Engineering at Purdue University. I've taught problem solving in this way for many, many years. It is time tested. It is a good problem solving technique, and I trust that this series of short videos has been helpful to you.